They never read a research paper in the whole life, but suddenly they have 10-year plans of where AI will be in 10 years. Would you trust? Yeah, but you would be like, well, yeah, here, take my tax money and protect me because you know where AI is going to be in 10 years. Did they predict ChatGPT? No, they didn't. Basically, are just flipping coins.
Welcome to Partner Path, a podcast that unpacks the venture capital and growth equity ecosystem from a junior perspective. Young entrepreneurs and investors have already had a massive impact on the industry, having started unicorns and launched billion-dollar funds. We discuss these success stories and more by sharing perspectives and advice from some of the industry's most prominent role models. This podcast expresses our views as of the date published and does not represent the views of and is not endorsed by any company for which we work.
We are excited to welcome Rickard Brüel Gabrielsson, an artificial intelligence researcher and co-founder of Unbox AI. Originally from Sweden, Rickard attended Stanford University for a bachelor's in mathematics and a master's in computer science. In 2020, Rickard started his PhD at MIT in artificial intelligence. Specifically, he focuses on foundation models and self-supervised learning. Rickard is also the co-founder of Unbox AI, a master AI foundation model for behavior and time series. Welcome, Rickard.
Thank you. Thanks for having me.
So born and raised in Sweden, you came to the US for college. It would be great if you could touch on what drew you to the United States and specifically Stanford from Sweden.
I said I want to go to the best schools in the world. And then I think it was my brother-in-law who said that those schools are in America, but they're super expensive and very hard to get into. But I was like 14 or something. I was like, hey, I'm gonna give this a try. Because I was from a small town in Sweden, so nobody that I knew of had ever gone to these schools. So for me, this was a very interesting challenge. I also felt I liked the liberal arts model where you don't get into a program and you get into a school and then you can focus on what you want in some sense and discover your major as you attend the college. And Stanford was exciting. It was, I was picking between the West Coast to the East Coast, and Stanford just sounded very exciting. That's why I picked Stanford. I was against the startup scene, and I was very much a physicist or a mathematician going into Stanford, and then I became an entrepreneur as well.
Because I was going to say, liberal arts, mathematician, physics, quite different from AI. So when did your interest in AI start?
Well, actually, I think those are quite similar to AI. I was always fascinated by self-developing systems and systems to learn, and the kind of math around that, like evolutionary process, etc. So I think that was a fairly natural thing. And also, not only is AI super fascinating from a theoretical perspective, and also trying to understand intelligence is also key in trying to understand ourselves. It involves somehow philosophy, a lot of things try to solve intelligence. And then it uses super interesting math, and it's very interesting in terms of the technology, but also the impact, the ability to have a big impact, and something that we've seen is very relevant in our era. Is super exciting. As a matter of fact, almost probably 95% of all the math majors at Stanford, I felt like they went into AI afterwards. So there was a huge demand for that and a willingness to switch.
So then did you feel that it was necessary to continue on that education with the master's and PhD in AI to either become a good founder or like to truly understand the space?
I do feel like college was a strange place where you get to know yourself. And it's about having a social life and trying different things. I don't feel that most people get serious into their interest in college, especially when it comes to research or heavier topics. In my master's, it was the first time I really started doing research for real. And it's super fascinating because you think that courses are going to prepare you for doing research. And like people's like, well, why should I take math if I'm going to do business or I'm going to be a construction worker or whatever? It's useless. But honestly, even all the undergrad math I didn't help me much at all for research, because there's such a big difference between sitting in front of a blank paper trying to solve something or understand the problem or what questions to ask, and solving something that's given to you and that you know that has an answer. Somehow you just learn that in a very different way. It's like reading a book about startups and actually doing it. It doesn't matter how many books about startups that you read. It's only when you get the skin in the game and you have the emotional trauma to actually learn and improve. And it's the same for research, honestly. Well, you only remember the intuitions and the big picture from classes. It's only when you get into details and building something from the ground up yourself that you actually start learning this concept in a real way.
And you've taken a really interesting approach to AI, more of a philosophical education grounding the group. I mean, I attended one of your talks and it was very comprehensible, and you've been studying this a while and it shows. And so I'm curious is why now? You've been paying attention to this for a while, but why is the rest of the world paying attention?
So I started doing something called unsupervised learning, which is basically a precursor to the breakthroughs we're seeing right now. So ChatGPT, Stable Diffusion, all the different breakthroughs we're seeing right now is basically because our models can learn without having label data, without relying on human beings in the loop. And the learning can be more a different way, with the learn from observing the world rather than having it feed to them. And that started off in unsupervised learning, but unsupervised learning uses very little learning. It's much more fancy math and not very powerful. And then what I'm doing is called self-supervised learning. It's just this context, these new powerful things where we put these deep new networks, a ton of parameters, and we let them play games by themselves, solve simple tasks that allows them to get at a deeper meaning of how the world works. I didn't think that the ChatGPT revolution is going to happen so soon, but I know it's going to come pretty soon. Even when BERT or Word, Embedding, etc. came out in 2013 or 2017, etc., right? I started seeing like, hey, this is really, really working well. It's transformed everything, this perspective of foundation models. And intelligence is really centralized and synergetic. But it took ChatGPT for good or for bad for, I think, the larger population to understand this. So what happens now is that, well, there's also now suddenly there's a lot of noise as well, I feel like. Before it was a little bit nice as well, because then it was a little bit less noise. This was brewing for a long time, but why now also think, well, give or take a few years, but that's just what happened. We're able to train these AI models without any human beings in the loop. And somehow humans are not the answers with the problems.
And before Will hops into building Unbox and kind of the deeper levels of AI, can you just touch on how foundation models work, such as the Chat GPTs of the world?
I think it pertains to how we as human beings learn things. We think that we learn a lot of things from our parents, from school, etc. That's too expensive and too inefficient. So most things that we know, we learn by ourselves. So if you take a sample of a dog, you don't learn what a dog is as you grow up by your parents telling you or from your emotions guiding, etc. You learn what a dog is by observing dogs in different contexts. So you see a dog that's walked by an owner with a leash, those relations, right, you observe in context and contextual clues allows you to understand what a dog is. It's something that's walked by an owner with a leash. It's something that chases frisbees when those are thrown, right? It might have antagonistic situation with cats. These relation observations allows you to understand what a dog is. And as you learn about dog by contrasting dogs with cats, you in turn learn what cats are. So this is how we kind of, by just observing the world, we start picking these things up, and now we let the computers do the same thing. That meaning is not abstract. It's not labeled to us. We think that we understand the world in a very abstract sense sometimes, but we don't. It's very relational. Everything is contextual. So the more relations that you're able to grasp, the more powerful understanding you get of each individual concept. These are the synergies or network effects. You understanding love helps you understand what a dog is because a dog loves his owner. So all these things add to your understanding and sophistication of your model. So why not train a huge, huge model on as much data as possible to just understand as many relations as possible? Because then you get the best model. Because the more relations, the better understanding, and then use that model in a wide array of downstream tasks where any of these concepts are involved. So that's exactly what a foundation model is. It's learned by this relational understanding from contextual clues and observing things, i.e. self-supervised learning, to get a very sophisticated understanding of tons of different relations and concepts. And then they say, like, great, we have this general model now, a foundation model, like a backbone that we can build everything else on top of. Because what any of those concepts are involved, this foundation model is applied and we use it. And the strength of the foundation model is in its broad intelligence and that it understands the relations of so many things.
Very helpful. Next would be great to just touch on exactly what you're building at Unbox.
Yeah, so at Unbox, we do generative AI for behavior and time series. I mean, ChatGPT is very impressive and useful, like a general assistant, and it's a foundation model for text-based language. So it solves a lot of different downstream tasks. It's very broad in its applicability and basically solves anything you want to do with text-based language, more or less. And you might have a foundation model for vision images like Stable Diffusion, but we're a foundation model for behavior and time series. So, for example, if you look at areas where that is most applicable, for example, retail, where we begin, why hasn't ChatGPT revolutionized retail at its core? It's a very useful assistant, but it hasn't revolutionized retail at its core. It's because retail at its core is not text-based language, it's consumption, and consumption is behavior. So we're a kind of foundation model intelligence for retail, for example, right? For behavior-driven problems and time series data. So it's a different domain of data types, applications, etc.
Could you compare and contrast the type of data that a ChatGPT would learn off of versus an Unbox, given the difference in foundation?
We have a lot of data that's hidden on companies' databases, like tons of behavioral points, right? So if you interact with a company, it's receipts, it's when you visit a store, etc., marketing emails, responses, clicks, searches, any kind of behavioral data that we get from you interacting with the company or retailer, for example. And of course, this data is not publicly available online, so it's not catched by our model is trained on public available data in this sense. And our use case is also this difference. We have not a fixed set of vocabulary in terms of the language. We have multi-modality data in terms of products, prices, anything else that can be in event when you interact with a company.
Would love to hear a little bit more about the potential applications that could be built on top of a foundational model like that.
Of course, now it's easier, but when we started off, which is before ChatGPT, you had to explain what a foundation model was, and nobody understand. And I think most people don't understand it still. People say like, well, is it a large language model? Because that's what people think of, but it's not really, right? It's really this, intelligence is centralized. It's synergetic. That's what intelligence is. We don't have a brain in each fingertip. We have one single brain. And somehow that's exactly what we're seeing as well when it comes to any particular domain where we want to build intelligence, is that the more data that you get, the better understanding you get. The more tasks you try to solve, the easier it becomes, not harder. In retail, for example, clients, we provide a really wide array of downstream tasks and solve a lot of the problems, all of the core problems. But that's a fairly complicated pitch. So what we say in the beginning is like, well, we have this downstream task that works well out of the box that we know is important for you. And those are, for example, for retailers, it's search, recommendation, and assortment. Those are our three main pillars that we come in and say, hey, try us out here. And then we win them over, and then they upgrade and use our model more broadly. And then they can also build their own customized solutions on top of it.
Would love to hear your strategy on pricing. I think there are a lot of different ways that these types of models have priced, including free versions. What is the strategy for the actual business model?
Charge as much as you can. So this is not my first rodeo in terms of a startup. I've wasted a lot of time in my life building things that nobody ended up using. So I promised myself that, hey, if I can't sell it, I won't build it. That's a great mentality for startup people to have, because it's a lot of wishful thinking of people do things for free or partnerships, and everybody's happy and everything's nice, and there's maybe investor money being spent, but really nobody gives a shit about what you're building. It's just kind of everybody's smiling because it's free. So make sure to charge early. That's the best feedback you can get. It's so fascinating how the conversations completely changes when you charge somebody. They're like, oh, this is fantastic, this is great. And they're like, okay, well, that's $30,000 a month. And they're like, okay, but then we don't want this or this. And we want more on these things because that's what actually drives value for us. Like suddenly you learn about the whole business, right? And that's what you want to do. You want to build a business. It's not about your smart ideas or building something stealth mode. It's about building a business, making money, right? Because money is the best feedback. It's not that money matters, it's that money is the only true way to know what you're creating is actually appreciated.
It's a fantastic lesson. I know you've had a lot of conversations with venture capitalists recently, and obviously that's a common theme in the show as well. Maybe could you just touch on some of the conversations you've been having around how venture capitalists are able to differentiate themselves in the eyes of a AI founder?
Yes, humility. A lot of VC funds a few months ago, they were crypto Web3, and then they changed. They said, oh, we've been in the AI space forever. It's like, no, I saw your LinkedIn just half a year ago, and then you were all about crypto and other things. Be a little bit like, hey, okay, we're excited about this space. It's hard to read what's going to happen, etc. Somehow that just makes me feel more safe with you, and it's not about just a fraud. don't try to be an expert if you're not, right? I think it's much more impressive to be like, hey, acknowledge your limitations, that you're switching now and focus on something, just to be a peer. That's the main one, I'd say.
And among the enterprise customers, do you think large language models will stay as an application that a third party provides and you pay off of consumption or whatever the pricing model is? Or do you think it's something that enterprises will look to bring in-house, just given you need to leverage proprietary data really to get the best use out of it?
Yes, you definitely have to. Because also like a lot of these companies now, they're just API or something on top of GPT-4, etc. Like I see this already, right? You get some attention in the beginning, but it takes basically a week to code up. Industry isn't stupid, right? They'd be like, well, we can code this up with consultants, whatever, over a week, and then we can combine our own data and we can own this and build this directly, remove the middleman that's just 15-year-old hacker. And they will, and then they incorporate their own data to get much better performance. That's happening already. Because also investors sort of don't know what's going on, so just jump on something that looks exciting. The market's going to mature, and a lot of these companies are going to disappear, and then bigger players that have the channels, distributions, and the data access points are going to build things on top of large language models that are super great. And then they probably will get those, beginning of those language models, the core model from a bigger institution like OpenAI, for example. I think that's fair. And also, like, I'm super excited, and it's going to happen soon as well when they incorporate videos, etc., into this training loop. The algorithms translate directly to other forms of data here. They can scale this up and get really, really good AGI models. Somehow, it's going to take a long time before the AGI is going to be something that everybody has. It's like your iPhone. So somehow you need to build things on top of that to be competitive and utilize your own data and domain expertise.
Where will we see fine-tuning workflows? For example, if a model is stateless and you build a business around that, it's going to be really hard. Whereas something stateful, like a vector database, you can constantly update. First, maybe it would be useful if you could touch on like vector databases and kind of ground the group on what they are, and then we can get into fine-tuning. I think that'd be helpful.
I actually don't see a distinction between fine-tuning and vector database, but let me tell you, a vector database, like a lot of things that these models put out as well, these are, how do you understand the meaning of a text sentence? It's very hard to summarize that into one single digit or something that's fixed or abstract. So you have, instead, a lot of things that before were more tabular are now vectors. And then in these vectors, you can have very interesting metric space, meaning these vectors have distances to each other. And the vectors that are close to each other in distance are somehow more related in terms of meaning. And these vectors can be super, super powerful because also they can capture, if they consist of like 756 numbers, they can capture a lot of different dimensionalities of yourself. Some numbers can pertain to if you take a photo, it can pertain to the colors, some can pertain to the face features, some can pertain to if it's what kind of car it would be or something like that. It just can capture a lot of things. Vector seems to be the way that AI likes to embed knowledge into these high dimensional vectors. So vector databases are super useful because you want to do a lot of things where you want to map a lot of your data and a lot of your components in your business to these vectors, and then you compute distances in these vectors to do certain operations. And that's where vector databases are very useful. And I would say that they're still useful even if you fine-tune your model, or if you don't. You can use a vector database for it anyways. This is like a nice abstraction to work with high-dimensional vectors and query them.
It sounds like there's no right or wrong answer, and they can almost work in parallel.
For us, for example, when we use vector databases, the only thing is that sometimes in AI as well, the training and deployment is quite similar and similar challenges. So sometimes if you want to optimize your model, you don't want to outsource the vector database part. You want to have a very integral part of your solution. It can be just more annoying to bring a third party to solve that, for example. That's what we've seen in our own work. It's like, well, they're nice to have a lot of things, but also they lock you down to a third party library or something. And that part is still very close to our solution, for example. We want to be flexible, move forward quickly, and iterate on our product and be very flexible. Then a vector database can sometimes hold us back because they need to update certain things, need to fix certain things, because they need to address and make a broad set of users happy, right?
Maybe you could explain how vector databases power the semantic search capabilities, because I think that's also an important development.
How do you encode semantics? in research in academia, we say I hate the word semantics because it doesn't mean anything, but what does it even mean, the semantics of something? It's fairly hard to find. It's multi-layered and nuanced, but you can embed semantics of something by having these high dimensional vectors, as I said before. How do you encode an image? Well, you can map it to 756 dimensional vector, like a long array of numbers. And then you can say, well, what is a similar image to this? And then you can look at the distances between those high dimensional vectors. Because if you look at the distance in the pixel space, you're going to miss a lot. And it's going to be very, very bad because the same phase shift a little bit. It's going to be very long distance in the pixel space. But if you have a good semantic embedding of your picture, they should still be very similar. You can somehow have a robust neural network that maps your input data like an image to a high dimensional embedding vector where distances correspond to a semantic assessment that human beings do. That's what also research shows. Research shows that these new models embed things, so distances corresponds very closely to how we human beings assess similarity and semantic similarity. But not, I mean, you talked about vector database, etc. I don't know if I'm a huge, I mean, yeah, it's not definitely going to be important, but also there's also fairly crowded now, and etc. And it's not that hard to fix yourself. I haven't decided yet exactly how I feel about vector databases. There definitely going to be a few companies that are going to be very, very important, very profitable, but also a little bit unclear how that space is going to develop completely.
Shifting towards some of the high level trends in generative AI, we'd love to get your opinion on some topics that are being discussed right now in the news. First is, McKinsey wrote a great piece of where generative AI's value will play into enterprise organizations, and they touched on customer operations, marketing and sales, software engineering, and R&D. So we're curious about where you think AI will have the biggest disruption within enterprise companies.
I think the biggest shift is going to be that every company is going to have one single core foundation model that solves all of its core AI tasks. It's going to be monopolized by a single foundation model. Maybe every company will not really be a company anymore. It's just more of a single foundation model that summarizes all of its data, intelligences, know-how, domain expertise, employees. So there'll be this huge, it'll just be these foundation models that compete against each other. You have like an Exxon oil foundation model that just has encapsulated all of the know-how, knowledge, data, etc., that Exxon has built up as their competitive advantage, these relationships and everything. And they're going to sell access to that model to other foundation models that they want to buy some services from it.
That model is going to require people. Who do you think the model will replace? And then what are going to be the new skills or jobs that'll come in to these organizations?
Most of it is going to be just to give data to these foundation models.
And then you let the model run.
Yeah, so you're feeding your intelligence to the model to make it better and better and apply it, I guess, in different places. This is, a very high level perspective. It sounds a little bit futuristic, of course. I go to a lot of these events where big European Union made a 10-year plan of what AI was going to do the next 10 years. They have no idea. What does McKinsey know? But they need to put something out. But there's very few people know exactly where this is going. And we know at least that most of them are going to be very wrong. So you can bet on that. And then I would also bet on things moving actually much quicker than we expect. So ChatGPT is cool, whatever, but just wait. Much more things are coming. It's going to happen very, very quickly. A lot of people are going to lose their jobs. They're going to be put in other jobs. So there's going to be a lot of unrest because there's going to be a lot of change. Whatever happens, even if you get new jobs, human beings don't like change. So historically, that's never been just taken graciously. With big changes comes big unrest.
Quickly on that concept that enterprises are turning into foundation models. Obviously, there's still some value to brand and other things within an enterprise, but the idea that enterprises will have a lot of value that is aggregated in a foundation model, to me, you think of the market cap of ExxonMobil, for example, it's $400-500 billion. It's a lot of value that sits in this foundation model. How do you think about security and the ability for enterprises to protect that domain expertise?
That's going to evolve like most of these things evolve. You do your best, you build these things, and you try to restrict things. And course, when something becomes more and more digital, it's going to be more vulnerable to hacking. It also becomes more centralized. I mean, what we're seeing now is also fairly short term. The reason why we have one brain per person and not one brain per humanity is because having one brain per humanity will be very fragile. So somehow we're in some middle land where we have one brain per person because it does it's centralized and synergetic, but also we want to be robust because evolution is, well, if I have one single brain and it stops working, then everybody's screwed. That kind of short-term optimization we're definitely seeing now, right? Where there's single models that do so much for us, and like ChatGPT being used everywhere. I think that's of course is from any perspective stupid and dangerous, but also of course very tempting and short-term beneficial. That's all, of course, I feel dangerous and makes us more fragile. Companies being too big to fail. That's also, I feel, very strange thing that we human beings have allowed and built up because we have built artificial systems, but nothing should be too big to fail. That's just everything will fail at some point. That's like the only eternal truth is that everything will fail at some point, and it needs to be able to fail. And I think the same for foundation model. We need to make sure that if ChatGPT in 20 years of a huge foundation models as our AGI that feeds most of our population like electricity, if it fails, we're fine. But honestly, I don't think human beings will ever be smart enough to make sure we're that long-term sustainable. We think we're very short-term. And that's the dangerous trend. Yeah, things becoming more and more centralized and rely on a single model. And if it breaks down, we're all screwed. And that's probably what's going to happen.
I'm curious, rooting for the smaller players here. Do you think that the smaller players almost have more room for innovation because they don't have that bureaucratic overhead?
When a lot of change happen quickly, there's a lot of opportunity now for smaller players to rise that know what's going on. If you ever work with a big company, you're always surprised by how slow they move and how everybody's responsibility is nobody's responsibility. Yeah, I think it's got probably the biggest wealth transformation that we've seen maybe ever. And that's exciting as well. Also, of course, dangerous and everything that happens when a lot of change happens. But there's a lot of room for small players. It's kind of a stochastic, chaotic state right now where some people go all in one direction and they turn out to be right. I mean, it's happened before, right? And then like Amazon, for example, whatever. And then that can happen just much faster thanks to technology because things move faster. It was harder somehow to do that before.
If you could pick any large generative AI company right now to go work at, where would you go?
Great question. John LeCun at Facebook, he seems like he's a little bit bitter on Twitter. And even if you call things out early and you were right, you think you're going to be, well, I told you so, but nobody cares. And somehow I feel like John LeCun has been right in a lot of things that he's been saying, and he built up, and now he's a little bit bitter because people don't give him the acknowledge that he was right about a lot of things. They just give it all to ChatGPT or somebody that built the interface. But John LeCun, I think, still fairly early was right about where this was going to go, etc. And he's very, very knowledgeable, and you could probably learn a lot from him. And then I'd say as well, Ilya at OpenAI, he's probably one of the key people behind their success and their bet on what they're doing. And also, you can learn a lot from him as well. And also, if you go to OpenAI and work there for a little bit, at least it gives you some hype you can use. Other people will like. That's where I would go because somehow brands matter.
Yeah. And you mentioned AGI. Could you just ground the audience on what AGI is and what the implications of achieving AGI are?
Nobody knows what AGI is really. People think it's a human level intelligence in its sophistication and broad applicability. Somehow we just want to make intelligence that seems fairly human. There's also what surprises us with ChatGPT. It's like, well, it seems to be much more human than anything we've seen before. That's what AGI has come to represent for a lot of people, is having this human-like intelligence. And I think there's a lot of room. If you want to create human intelligence, just create a baby. I think there's a lot of room for specialized and superhuman intelligence in different domains. And I think there's going to be some AGI that interfaces with us as human beings and then uses a lot of other intelligence as tools. Like we use a calculator computer. It's going to be a lot of, at least for some time, it's going to be a lot of interfacing of foundation models.
How do you think about governance of AGI?
The biggest thing is to be reactive. and quick when something happens. If you're in a startup as well, don't try to anticipate what's going to happen. People love to be like, well, in 5 years, we're going to be this and this and this. And they sit down and think about this and trying to predict the future. It's like this black swan. Don't try to predict the future as much as creating the future, and iterate and work on something, understand a particular domain. Somehow human beings are way too stupid to think 50 steps in advance in a row or something. It's just like we're not very good at that, and it's very complicated. The world is perhaps just doesn't work that way. It's too chaotic. Be prepared that something unknown is going to happen. So when it happens, you can do something about it. So don't sit down and build big systems around your predictions. Don't be too fragile. Use like nature as a guiding wisdom of how to build systems that are robust. Because like nature doesn't know there's going to be a volcano. They're like, well, it doesn't use that kind of reasoning. Like, hey, in 5 years, it's going to be a volcano, so we're going to build a huge thing around that volcano. Predict the future in that way is too chaotic. So somehow you just need to be robust. Like, well, there's going to be a volcano that erupts. So if any volcano erupts, we're going to be fine because we're robust to that. It's like the same when it comes to governance. I actually like, but it's the bureaucracy as well. When I hear these ex-politicians talking about the future of AI, I mean, of course, the community doesn't know where AI is going. They've never read a research paper in their whole life, but suddenly they have 10-year plans of where AI will be in 10 years. Would you trust? Yeah, but you would be like, well, yeah, here, take my tax money and protect me because you know where AI is going to be in 10 years. Did they predict ChatGPT? No, they didn't. Basically, are just flipping coins.
So to end, we have 2 questions. The first one is, what motivates you to work hard?
What motivates me to work hard is having an impact. I feel on this planet with unique abilities and potential, and I feel there's a lot of fulfillment in realizing that potential, your own unique potential, and seeing that affect people around you. I just want to have a good impact on the world. It gives me a lot of happiness. It gives me meaning, fulfillment, and I need it. I can't optimize for happiness. Happiness is a very fickle thing, elusive. So impact is better to optimize for. It's somehow more stable.
And what's one piece of advice you would give your younger self?
One thing that I'm very grateful for is a lot of times it's very tempting to push things off. I'd love to start working on this crazy, or I start looking into this research project, but then you'd be like, no, I'm not well read enough. Or like, I don't have the PhD yet. And then I'm going to do this and this. And then I'm going to start looking at the things that really amaze me. Because I need to do these check boxes first. If you can just go straight working on the things that you care about, try to do this as early as possible. Because yes, it might be inefficient to go straight for the thing, and you maybe shouldn't push everything aside, but try to spend some time pursuing your absolute dream and fascination, at least a little bit every day, a week. It's going to be inefficient, and maybe it's going to be very intractable because you don't have the skills, but you're going to learn a lot in the process. That's going to guide all your other pursuits. You'll be like, hey, I didn't know how these things work, and it's going to inform your PhD, it's going to inform your school studies, it's going to inform your startup. You're going to learn a lot by going straight for the things that you care about, even though it feels that, even if it's like, yeah, I'm not going to make it, still go for it because you're going to learn so much in the process. You're going to be like, well, actually, this is not what you want to do. This is not what you care about. And there was just something else. But it's better to realize that when you're early in the process than after. There's a lot of people everywhere in academia as well. Well, they become a professor first, and then they feel like they have a tenure and stuff, and now they want to focus on the problems that they actually thought was the most interesting and important ones. And then they're like, holy moly, I did a lot of wrong life decisions because I didn't know, I wasn't an expert at this problem. Because someone is a difference anticipating and actually working on it. Like if you want to do a startup, don't start your first startup when you're 40, when you're like secure, you have the expertise. Like start as soon as possible to understand how you build a startup, if it's actually what you want to do, if it's like something you think you want to do, actually want to do, and how it works. What's the skill that you need to use? Because also it takes a lot of time and emotional investment and failure to learn those things, whatever it is you want to learn. Like it takes a lot of failure and emotional pain or whatever to learn those things, and it's going to be harder and harder the older you get. I'm 30 now. I'm not going to change too much. Most of the things that I learned in a very intuitive, deep level, I've already learned. And it can be very painful to learn those things, but it's better to have that pain earlier than later, kind of to minimize regret.
It's an incredible piece of advice and a great note to end on. Rickard, thanks so much for jumping on the podcast and sharing your perspectives and advice on AI in broadly.